All right, everybody, we are ready to get started. How's everyone doing today? Woohoo, excellent. Welcome to the Morrison Planetarium. My name is Mary. I use she and her pronouns, and I'm going to be your presenter for our tour of the universe today. And just curious, how many of you saw a show in here earlier today? If anybody? A few people. Awesome. How many of you, if you didn't see a show in here earlier today, have seen one of our shows before? Okay, a lot of you. Awesome. So if you have seen one of our shows before, most of the shows that we do throughout the day are pre-recorded movies, sort of, with a short section where someone like me, a presenter, can talk to you about a particular astronomy topic. This show, though, is one of my favorite to give because this show is completely live. I'm going to be our pilot as we fly through the universe today. We're going to start out at Earth. We're going to zoom out as far as we can out into space, and I'll take us safely home at the end of the show. But in order for us to go on this journey, I do have to head all the way up the stairs to our pilot's booth, which is at the very top of the room where I'll be controlling the show from. And on my way up, I have a few quick planetarium rules to go over. So first of all, please no eating or drinking while you're in the planetarium today. If you did bring any food or drink, that's fine. Just make sure it stays sealed and put away. While you're following that first rule, the next rule should be pretty easy. Please make sure to keep your mask on for the entire show and make sure it's on all the way. If you have a cell phone, a camera, a tablet, anything at all that could give off light or sound, both of those can be very distracting in here, so we want to make sure that those are all put away during the whole show. And for your safety in this dark theater, and with these very steep stairs we have here, we do highly recommend staying seated throughout the entire show. But if you find that for some reason you need to leave early, the exits are at the top of the stairs on either side. Just know if you leave, you won't be able to get back in. And last but not least, this can create a very immersive experience. And while I do my best, not a perfect pilot, so if at any point throughout the show you feel any dizziness, any motion sensitivity, just go ahead and close your eyes for a few seconds. And that will help your brain remember that you're just sitting in a chair in a planetarium, not actually flying around in space. All right, so without further ado, go ahead and sit back, relax, give me a few moments to get into our control booth here, and we will get started. All right, so we are starting our tour of the universe today, relatively close to home, just a few hundred miles above the Earth's surface at the International Space Station. And I always like to start out at the International Space Station because it gives us just a little bit of perspective on the incredible distances that we are going to cover today. Because, like I mentioned, we're going to start out at Earth and we're going to zoom out as far as we can out into space in our tour in the next 20-ish minutes here. But this gives us a little perspective because the International Space Station is where, as far as humans travel out into space right now. And today we'll see how far human beings have traveled in general. We'll see how far our spacecraft have traveled. We'll see how far anything we've sent out into space has traveled. And we're going to go even farther than that. But the International Space Station, pretty close by. This is as far as we go right now when it comes to people going out into space. And there are roughly 6 or so astronauts on the International Space Station at any one time. And it's the largest object that we've put up into space so far as well, about the size of an American football field, or you can also compare it to the building we're in. It's roughly the same size as the Academy. And as I zoom away from the International Space Station, I'm also going to bring up a yellow line so we can see where its orbit is, so where it's orbiting around our planet. And something really cool about this tour that we're going on today is that I'm using a software called OpenSpace, which is a free open source planetarium software. So everything we're going to see today is actual images and actual data of the locations that we're going to go to. So the International Space Station, for example, this is where the International Space Station is right now. And if you want to, there's a quick Googling you can do, or there's a website that you can go to show you where the International Space Station is at any given time. You can see if it's going to fly over you any particular night. And the likelihood of it flying over is actually pretty common because they're going around the Earth very quickly. It only takes about 90 minutes for them to orbit us once. So they're going around us pretty fast and pretty often. But right now, apparently, they're over by Australia. But I'm going to keep on zooming out because we're not going to spend too much time at any one particular place today, since we do have to cover the entire universe in the next 20 minutes. So I'm going to switch our focus now to our closest natural neighbor in space, the moon. Now, I don't know exactly where the moon is right now, so this might swing our view around. So if this makes you dizzy, close your eyes for a second. Okay, not too far away. And we're going to fly over to the moon, our closest natural neighbor. And I say closest natural neighbor because, like the International Space Station, we have a lot of human-made objects that are going around the Earth. A lot of human-made satellites, you might call them. But the moon is our closest natural satellite going around our planet. But even though the moon is our closest natural object to us out here in our solar system, it's still about 250,000 miles away. And this is the farthest that humans have traveled out into space so far. The Apollo astronauts came out here in the 1960s. And even though it's our closest neighbor, it took them a couple of days or so to get here because it is quite far away. As we go farther and farther out today, we're going to see distances of millions of miles, billions of miles, trillions of miles, and pretty quickly, it's not going to make a whole lot of sense if I keep telling you how far we've gone in terms of miles or kilometers or other distance measurements like that. So here at the moon, I like to introduce an idea that I'm going to use throughout the rest of the show. I'm going to think about how far we're going in terms of the speed of light. So imagine, if you will, going the fastest speed we know of in the entire universe, the speed of light. If we were going at that incredible speed, it would have taken us about 1.5 seconds to get to the moon from Earth. So one way we can think about that is that the moon is a distance of 1.5 light seconds from us. So that's how long it would take light to travel here. So to travel here, traveling at the speed of light, probably would have taken us about the same amount of time that it did here in OpenSpace. Pretty quick. And as I zoom back out away from the moon, I'll bring up some blue lines now to show us where the orbit of the moon is. And I'll bring up some more to show us where the orbits of the planets are, so we can keep track of things as we go out farther into our solar system. So you can see that orbit of the moon around the Earth. And then we're also going to see the orbit of the Earth around the sun, as well as the other planets in our solar system. And I'm going to focus for just a moment on the very center of our solar system, the closest star to us, the sun. Once I zoom out a little bit more. Now, if we were traveling at the speed of light, it would take us roughly 8.5 minutes to get to the sun from Earth. So the sun is about 8.5 light minutes away from us. Now, there's a few different ways I like to think about that. One way is that if the sun just disappeared, we wouldn't know about it for 8.5 minutes. But don't worry, there's no reason why the sun would just disappear. I wouldn't have to worry too much about that. Another way I like to think about it is that if you walk outside today and you look up at the sun, first of all, never ever look at the sun. It's very bad for your eyes. But if you did, that's what the sun looked like 8.5 minutes ago. Or a more safe option, if you look at the moon, that's what the moon looked like 1.5 seconds ago. And within the few light minutes of distance that we're seeing here, we're seeing the orbits of the smaller rocky planets in our solar system. So closest to the sun, we've got the orbit of Mercury. And then farther out, we've got the orbit of Venus, and then us, Earth, and Mars. And then farther out still, we're seeing the orbits of the gas giant planets, Jupiter and Saturn. And beyond that, we've got Uranus and Neptune. But as I zoom out, you may notice that there's a pretty sizable gap here in between Mars and Jupiter. But that's not totally empty space. There are a lot of objects actually in between Mars and Jupiter in an area we call the Asteroid Belt. but we can't see them because they're pretty small and they're not giving off their own light. They're just reflecting light from the sun. So they're very, very dim. So let me make them much brighter than normal so we can see where they are, all those little green dots. So those are where most of the smaller rocky objects in our solar system reside, in between Mars and Jupiter. But not all of them. There are asteroids other places throughout our solar system, but most of the asteroids are in between Mars and Jupiter. So now we're seeing all the major planets, the 8 planets that I mentioned before. But I do want to bring up one more trail here, my favorite dwarf planet, Pluto. And to this day, I do still sometimes, where is Pluto? I do still sometimes get questions about Pluto. People are very interested in Pluto. People ask questions like, what happened to Pluto? Why isn't Pluto a planet anymore? Did Pluto blow up? Is Pluto still in the solar system? Why do you hate Pluto? And I'm here to tell you, I don't hate Pluto. I think it's delightful. I love it. It's great. But the reason that we don't call Pluto a planet anymore has to do with some other objects that are very dim and very far away from the sun, way out here by Pluto's orbit. I'm going to show you where those are. It's going to pop up kind of abruptly, so just a warning. I'm going to show you where we find the Trans-Neptunian objects. So these are objects that orbit mostly outside of Neptune's orbit. You can see that a lot of these have kind of wild orbits going all over the place. But if you look at the majority of them, they make kind of another belt farther out in the solar system, out by Pluto, kind of similar to the asteroid belt, but much bigger and much farther away. And that's what we now call the Kuiper Belt, which is made up of a lot of small objects, a lot of icy objects, but a few objects that are around the size of Pluto. And we didn't know about these objects until really recently. It wasn't until the late 90s and early 2000s, as we started to get better telescopes and better technology, that we were able to detect these objects way out here. So as astronomers started to find more and more of these, they came up with a conundrum of, well, do we call the bigger ones in the Kuiper Belt planets as well? Do we come up with another category? And throughout a process and a voting thing and some astronomers getting together back in 2006, they determined that Pluto would be part of a new category of objects called dwarf planets, rather than of one of the 8 official planets. And that's because of all that stuff that is in Pluto's orbit. One of the requirements currently for a planet is that it has to have cleared out its orbit and have a relatively cleared out orbit. And since little Pluto did not fulfill that requirement, it was changed to a different category. But I say that this is a triumph because during this process, a less well-known object over in the asteroid belt in between Mars and Jupiter called Ceres was promoted to dwarf planet before it was just called an asteroid. So I think it's a happy story of this changing of categories, and Pluto is still cool and interesting. And I encourage you to look up facts about Pluto. It's a very cool place. And Pluto has something about it that a couple of the other planets in our solar system do not have, which is that we sent a spacecraft specifically just to fly by Pluto. And we can see where that spacecraft is now, which we'll see show up in just a second here, as well as a few other spacecraft that we have sent out into space, because it's been a minute here since we've checked in how far we've gone. So if you remember, going to the moon would have taken us about 1.5 seconds traveling at the speed of light. If we were to travel to the sun, that would have taken us about 8.5 minutes. Out here by Pluto, to get from one side of Pluto's orbit to the other, that would take us about 9 or so hours. So we're out to a few light hours of distance out here by Pluto. And the New Horizons spacecraft flew by Pluto just a few years ago, back in 2015, and its trajectory is up here, as well as the Voyager 1 and 2 spacecraft and the Pioneer 10 and 11 spacecraft. So these are all headed out of our solar system. These are all traveling incredibly fast, and they were sent in a direction that they will leave our solar system behind and go out into space. And very recently, the Voyager spacecraft, we're pretty sure have pretty officially now, I think, left our solar system behind. It's a little tricky to try to figure out exactly where that happens, but the Voyager missions are getting pretty far out, we think, beyond some of where the sun's influence is, but not all of it necessarily. And and let me, before we zoom out too much, just a quick note that none of these spacecraft have gone as far as light could travel in a day yet. So we still have a long ways to go. We're only at light days of distance right now. But exactly where our solar system begins and where our solar system ends is kind of a tricky idea. But if we get far enough out, it won't be a question anymore as we fly past other stars in our galaxy. And we're now seeing the sun at its true brightness. Before, I was dimming it down quite a bit so we could actually see the other things in our solar system a bit better. Now, this is what the sun would look like if we were really this far out in space compared to the other stars. So now that we're really far out, we're starting to fly past some of the other stars in our galaxy. And if we were traveling at the speed of light, it would take us a really long time to even get to our closest neighbor here in interstellar space. For example, if we wanted to get to the closest star to us, Proxima Centauri, which is part of the Alpha Centauri system, that would take us about 4 years, even if we were traveling the fastest speed we know of, the speed of light. So things are really spread out here. There's a reason we call it space. There's a lot of space in between things when you get out to where the stars are, especially, and beyond. But something really interesting, a very active part of astronomy and science right now is that a lot of astronomers are studying these stars that we're seeing, that we're flying past right now, some of the closest stars to us. And they're studying not just the stars, but also the objects that are going around these stars. Another relatively recent area that we've learned about in astronomy is where there are planets around other stars in our galaxy. So all these blue markers that I put up here, these are showing us locations of exoplanets, planets that are outside of our solar system. So every single one of these markers is a star that has at least one exoplanet. Some of these have multiple exoplanets. And so far, we've found over 4,000 exoplanets, and we've only been finding these since the mid-1990s. So there's a lot more to find out there. We think there might be at least one exoplanet around most, if not all, stars. Probably a lot of these have exoplanets, even if we haven't confirmed them yet. And out here by where a lot of these exoplanets are is also the last time that I can show you where anything that we've sent out into space has gone. Because we already saw how far our spacecraft have gone. Those 5 that I showed you before, those are the farthest spacecraft that we have sent out so far, maybe to the edge of our solar system at the farthest. So anything we're seeing out here is not because we've sent something out here to observe these objects. It's because the light of these objects has traveled to us and we've seen them in our telescopes. But there is one more type of thing that we have sent out into space, and we're seeing where that is right now with this grid here, and that is the radiosphere. So we have radio signals that are leaving our planet and flying off into space, and we've had strong enough radio signals to escape our planet since the 1930s, so about 90 years ago. And those radio signals that are going out into space, they are traveling at the speed of light. And something kind of interesting about space travel out here is that if something goes out into space, as long as it doesn't run into anything, it's going to just keep on going at the same speed that it started with. So those radio signals, if they don't run into anything, which seems likely given how spread out things are out here, they'll just keep on going and going and going at the speed of light. So the farthest that any of those could have gone is the edge of that blue sphere there. The edge of our radiosphere is the farthest that any of our signals could have reached, about 90 light years from us in any direction. But we got to keep on going because we still have a long way to cover if we're going to fly through everything we see in the universe. So I'm going to bring down the exoplanets here, but I am going to keep up the radiosphere. I like to keep an eye on it as we zoom farther out. And you'll notice that our model of our galaxy is shifting right now. Before, we were seeing the closer stars to us. We were also in the background seeing kind of what it looks like if you were to see our Milky Way galaxy, if you went out and looked at the sky somewhere really, really, really dark. But now we're using a different kind of model of what we think our Milky Way galaxy would look like if we could go outside of it. So again, like we saw, we have not sent anything out this far. We have not sent spacecraft out this far to snap a picture, turn around and look at our galaxy. But we do have a lot of amazing instruments here on Earth or with our space telescopes that can see in various forms of light so that we can build a pretty accurate model of what we do think it would look like if we could go out this far. So this isn't an actual picture, but this is based on a lot of actual pictures that we do have from various telescopes that we have. So we live in this spiral galaxy, and you can see a very bright glow at the center of our galaxy, which is where there are a lot of stars more closely packed together. If you could see past all those stars at the center of our galaxy to the very, 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 very center, you would see nothing, because right at the center of our galaxy is a supermassive black hole. And we think that there might be supermassive black holes at the center of most major galaxies out there in the universe, which is pretty cool. And I'll give you a second to look for the radiospheres. Can you still spot it? That little tiny dot towards the upper left over there, that little blue dot, that is our radiosphere. That's how far any of our radio signals have traveled so far. Because out here at our galaxy, we're now up to distances of thousands of light years. If we wanted to travel across the disk of our galaxy, which let me show you how flat this thing is. So if we wanted to go across the wide part of it, the flat or the disk part of our galaxy, that would take us about 100,000 years to travel from one side to the other. If we were to travel from the top to bottom, so to speak, it would take a lot less time because you can see our galaxy is quite flat compared to how wide it is. But let's keep on going. We still have quite a ways to go because as we zoom away from our galaxy, the Milky Way, we're going to start to fly past other galaxies. Now, all these other dots that you're seeing in the background and that we're flying past, every single one of those dots, those aren't individual stars anymore. Those are individual galaxies. And all of these galaxies, they have their own billions or sometimes trillions of stars. And if you're curious about what these colors are, I'm sad to tell you that these are not the actual colors of these galaxies, though I think that would be fun if it looked like cosmic Skittles out here in the universe. But no, these colors are the just color coding that we've decided on for these galaxies. So usually when we color code these groups of galaxies, it's often which data set they're part of. So perhaps what telescope or what group of people mapped out where that galaxy was. And also we can sometimes group things together depending on, is that galaxy part of a cluster of galaxies or a group of galaxies, things like that. So this is an actual map. This is where we've mapped out where these galaxies are relative to us. We've seen the light of these galaxies with our telescopes. And because this is a real map, it means that at a certain point, our map looks kind of weird. Right around here, if you look at the top and the bottom of our view, there's a pretty sizable pair of gaps that we're seeing here. And that's not because we don't think there are galaxies over in those directions. We do think there are probably just as many galaxies in those directions, but those gaps line up really nicely with where our galaxy is. If you could still see the Milky Way, the disk of our Milky Way would line up perfectly with where these gaps are, because our galaxy has a lot of gas, dust, stars, all sorts of stuff in it. And when we try to look over in those directions, that's in the same direction as our own galaxy, which is blocking our view, making it hard to see over there. So there are even more galaxies than this, but this is just what we've mapped out so far. And beyond these galaxies, the farthest galaxies, some of the dots that we'll see are also the farthest objects that we can see in our universe. Bright quasars, we think perhaps the beginning of some of these galaxies, the bright cores of them. And let's check in real quick with how far we've gone. We've did a really big distance leap here. When we were back at the Milky Way, that was a distance of about 100,000 light years to go across our galaxy. Now we're looking at distances of billions of light years. We're probably a few billion light years out at this point. And brings us to an interesting idea as well, which is that we're kind of time traveling, sort of, when we're looking at these objects that are incredibly far away. Because if you recall at the beginning of the show, I mentioned how if you look at the sun, which again, do not do that, don't look at the sun. But if you did, that's how it would have looked 8.5 minutes ago. Well, this is what our universe was like billions of years ago, because it takes so long for that light to travel to us and get into our telescopes that by the time we're seeing it, it's what it looked like in the past. And because of that, that means there's only so far that we can go. There is an edge to everything we can see in our entire universe. And that edge is what we call the edge of the observable universe, the cosmic microwave background, which we're seeing all over the place now. Now, if you walk outside tonight and if it's nice and clear out with no clouds and you look up at the sky, you're not going to see this everywhere you look. Thank goodness. That would scare me if I looked up in the sky and saw this. But if you did walk outside and if you had microwave vision, so if you could see microwave light, which is the lower energy form of light that our eyes can't see, but some of our telescopes can, then you would see this every single place you look in the sky. And this was a few 100,000 years after the Big Bang, when light was first able to go out and expand in all directions and just kind of spread out into space. So this is the earliest light that we can see. I like to think of this as the baby picture of our universe, since it's the earliest that we can look back in time and in space. Pretty cool. But since this is at the edge of everything we can see in our entire universe, that means, I'm sorry, I can't take you any farther. So to end our journey today, we're going to fly on back home. Now keep in mind, if we were really this far out in space and if we were really traveling at the speed of light, this journey home would take us at least 13 billion years. But thankfully, we're in the planetarium. It should only take a minute or two. So here we go. And as we fly on back home, one last thing I do like to leave folks with is that all this that we've been looking at, these stars, galaxies, planets, dwarf planets, gas, dust, cosmic microwave background, everything we can see is actually a very small part of everything we know to be out there. There's some really mysterious things like dark energy and dark matter that scientists are still trying to figure out exactly what they are. Dark energy is some mysterious force that is causing space itself to accelerate as it expands. Dark matter is some mysterious substance that doesn't seem to interact with light at all, but we see a lot of evidence of it, especially at the edge of galaxies. And we call them these things dark energy and dark matter because we're still not quite sure what they are exactly, but we do know that they make up about 96% of our universe. So all of this that we can see is a teeny tiny portion of everything that's out there. And that can sometimes make people feel kind of uncomfortable and small. And I agree, makes me feel kind of uncomfortable sometimes too. But another way I like to think of it is that, well, we are this one tiny dot in this gigantic universe. But look at all of this that we have found so far, almost entirely by just looking through telescopes. And there is a whole lot more to discover and a whole lot more to learn about. And that's really exciting. So with that thought in mind, let's head back into our galaxy, the Milky Way. I can already see our radiosphere, the edge of everything that our humanity has sent out into space. And I always feel a little bit of relief when we re-enter the radiosphere, re-enter our little human realm of the universe. And we're going to head back to the sun. We'll see it show up in just a minute, and it'll start to look more familiar, not just like one of these other stars that we see at night when we go out and do some stargazing. We're going to fly past all these spacecraft that we have sent out really far, even beyond our solar system, and heading back to the third planet from the sun, the only place in all of this where we have found life at all so far. And we may have crashed the computer, but it's fine because we're already home. All right, there we go. And we're back home. Hooray! So with that, I want to thank you all for joining me today for our tour of the universe. I hope you enjoyed flying around in space with me, and I hope you will all enjoy the rest of your evening. Thank you so much for coming.